This is the kind of question where, yeah, you could think about it and understand all the logic behind it, or you can just go to Desmos. Now, one thing you should know instantly is the answer can never be B. These are two lines, and so lines don't curve. They just go on in one direction forever. So at most, oh, well, I shouldn't say that, but no matter what, they can't have two intersections. They can't cross each other and then somehow recross another place. It's got to be at most one regular solution, or if they're parallel, they have no solutions. Or if they overlap completely, then they have infinitely many solutions. So we can see what's going on just by going to the Desmos calculator, opening it up, and just typing these in. So negative 12 x, just make sure you get all the negatives and everything, plus 14y is equal to 36. And then on the second line here, we go negative 6x plus 7y is equal to negative 18. And it looks like, yeah, they have no solutions because these are probably parallel, right? So in a pinch, if you don't really know what's going on, at the very least, these look like they're going in the same direction. We can zoom out. We can kind of see that, yeah, they don't seem to be bending towards each other. It's kind of hard to see with, it's like if we zoom out too much, now they start to look like they overlap. So that can happen, but you can kind of tell they're not curving towards each other. We can move in either direction for a long time, and it seems like we're good. So that means that there are no solutions because they don't intersect. They go on forever in the same direction. Now, if we really wanted to prove it, we could do it with algebra. Basically, the way I like to think of these situations is that we want to get back to y equals mx plus b, and then we're mostly comparing the slopes. If they have the same slope, then they are either going to intersect 0 times or infinitely many times. So let's take a look at how we would do that. I would recognize that, well, we can just do it by kind of very blandly going through y equals mx plus b. So let's add 6x to this side, So let's come down here. We'd have 7y is equal to 6x minus 18, divided by 7, divided by 7, divided by 7. So y is equal to 6/7 x minus 18/7, right? So notice I'm not putting everything over 7. I'm splitting it apart because I want to see the m and the b separately. Now I can do the same thing here. I'm going to add 12x to both sides. And it's an ugly 2, but there you go. So we get 14y is equal to 12x plus 36, divide by 14, divide by 14, divide by 14. Now the thing that happens here is we can reduce these fractions because they have a common term. So y, now what goes into both of these? Well, 2 goes into 12, that's 6. 2 goes into 14, that's 7. So there you go, 6/7 x. 2 goes into 36, that's 18. 2 goes into 14, that's 7. So plus 18/7. So we can see the similarity here. We have the same slope, which means that these things it's not going to be exactly 1. That's when they have different slopes. And then because they have different y-intercepts as well, they are close, but they're not the same. These are going to be 0 solutions. So this is actually both of these are same slope, but then they have the same y-intercept would be infinitely many solutions because then it's literally the exact same line, but then these are going to be different y-intercepts, and that's what we've got here. So, that is the more technical way to really prove it. We could have taken a little bit of a shortcut here just by recognizing that if we multiply this by 2, we kind of get something that looks a little bit like the top one, right? Negative 12x plus 14y equals negative 36. And without rearranging it, some of you are going to know that the negative 12 and the plus 14 are going to have the same slope, but then the negative 36 versus the positive 36 is going to give you a different y-intercept. And you can kind of see that without moving things around. But I've seen SAT questions where there's been those kinds of little quick things we can do, but because of differences in the negatives and other little subtle things in the question, we can actually get it wrong. It may look like it's the same slope, but then something is changing in a weird way, and then it's not. So the safest way is probably just going to Desmos, like I said, but if you are going to do it algebraically, I recommend getting it back to y equals mx plus b format so you can actually see the slope and the y-intercept as individual terms and compare them manually. There will definitely be questions where we can't use Desmos, where that move of getting back to y equals mx plus b is going to be the right way to go. This is a very common topic on the SAT, so you want to memorize the stuff that I wrote down here and have yourself a bunch of ways that you might be able to answer it.